mechanical adaptations that we've done in the past. And I'm going to encourage everybody to mute their microphones unless you have a question, and then we can chime in, and feel free to have any questions at any time. Okay? The first example that we have here this morning is something that we did for the New Orleans Sewage and Water Board on a 7-megawatt dealer valve steam turbine. This is actually where we removed the dealer valve mechanical or hydromechanical governor, and we installed a Woodward hydraulic amplifier, which you can see right here in the picture. And we were, of course, controlling that with a Woodward 505. This is a 25 hertz generator, so it was a pretty unique application. The next one here is for TAW Aspen, which was a 54 megawatt GE steam turbine. Originally, this had what I call the GE 3-arm governor, which if any of y'all are familiar with that, you see the encasing here. If you can follow my cursor, you'll see that where the old governor used to have a big cover that used to go on it, and you had your power piston used to push up through the center. And we removed all of the old GE electric and hydraulic devices that were in this enclosure here. And we just went straight to this with a Parker actuator operating a pilot valve. We've done this several different ways. This just happens to be one that we've done recently. This next one here we did for Evonik Chemical and outside of Mobile, Alabama, and it's a 1.2 megawatt Dresser steam turbine. It was pushing a mechanical load, and this, of course, is you remove the hydromechanical governor that was operating the steam valve, and we went in with the Valtek actuator with pneumatics, and I'm sure that we more than likely had a Peak 150 that was doing the control for this turbine. This is one, Dow Chemical. It's pretty unique because it was outside, and not only that, we used a Valtek 50. It's not rare that we used a Valtek 50. We generally standardize on a 25, but this happened to be a much larger machine, and we needed the force to operate the steam valve. It was a pretty nice little project. Here, Georgia Pacific, where the customer asked if we could also use the Fisher 585, and this is our universal adapter with a Fisher 585 actuator on it. We can use just about any pneumatic actuator as long as the customer tells us what his preferences are. This is a little illustration that shows how our universal adapter goes together. Makes it kind of neat, so if you have a customer that is trying to do this himself, he can kind of get an idea of the steps that he has to take to put it together. The next one is our 90-degree adapter, which is basically the same thing. And if you have a customer that has something where you might have something that would interfere with the steam valve, if you wanted to go directly onto it, and we have this 90-degree adapter, and this just shows you how it operates. Here's another an adaptation we did with the GCS, for GCS with the LVDT position feedback. Customer needed to get that information back, and we were able to tie in this LVDT and put it right on there so he could do that. So if anybody has an application where they may need something like that, this is a pretty nice little adapter for it. This was in Covington, Virginia. This was on a extraction machine, and what a 28 megawatt GE steam turbine. And what this is 2 rotary adapters, or rotary actuators, I should say. And what we have here is we tied directly to the valve racks instead of going through like a linear type of operation where we would go through the gear and cam arrangement. We just went directly to it, so we rotate these racks with these linear actuators. This was a little system here. We did this for Dow Chemical, GE steam turbine compressor. This is also an extraction turbine, but the customer asked us to, instead of using a Woodward or a Parker or any of the other devices, they asked us to use the Voith. So what we did is we took the Voith linear actuator, and if you can see this, there was just a pilot valve where my cursor is right now. There was just a pilot valve right here with the old system used to attach to. So what we did is we put the adapter in, and then we tied the Voith actuator directly to the pilot valve. And we had to have an LVDT feedback, so we had this remote LVDT feedback that goes directly onto the rack to the main power piston of the turbine. You can see over here on the left side, it kind of, maybe you can see it a little bit better. This is another project we're doing at a 30 megawatt steam turbine, also a 25 hertz generator, that we're at the New Orleans Sewage and Water Board. And we removed the old hydromechanical devices that were on there to move the rack. And we used this Parker actuator, and we tied back into the exact same footprint that the old system was in. Just going to be a lot cleaner. And of course, we're going to have a 505 operating the steam turbine or controlling it. This was kind of a unique situation here. This was a dresser-ran 20 megawatt steam turbine, and what we did is we had a Parker linear actuator, but then we retrofitted the Woodward EHPS servo on to operate the Parker actuator. And if you can see over on the right where my cursor is, we just basically tied in the porting to make the actuation work. Okay. For our speed, we have the speed sensing arrangements that we've used at GCS. This is one here on an Elliott steam turbine where you have, I guess in the old days we used to just need 2 mag pickups or 3 mag pickups. Now when we're using the overspeed, I should say when we're using the Woodward ProTech, we need 6 mag pickups. So we put a double row gear in there, and we go to exact same spot that the old Woodward PGPL used to fit into, and it kind of gives you an idea of how everything looks on the inside here on the left. And this is what it on the right tells you what it looks like after it's installed. Evergreen packaging, we did a 7.5 megawatt GE steam turbine here, and instead of looking at the outside row of the gear teeth, we went in with a disc. This is a pretty neat design. We've done this on several different turbines, and this works really well, and it gives you an opportunity to put multiple speed pickups in a small area if you can get to the front of the rotor like we could on this particular one. This is another design of that same I should say the same idea, where we have the speed disc that goes right to the very end of the rotor, and then we can come in and we can put our mag pickups around. This is something that we did for a little refinery in Arkansas, Cross Oil. It was on an Elliott steam turbine, and we used basically the idea of our GCS Tach Kit, and we removed the TG governor, and we were able to put a little bit larger gear in there with 30 teeth, and we were able to get 6 mag pickups, or the availability of 6 mag pickups. But this is pretty nice because you remove a TG governor and this will fit right back into the same spot. So installation's very easy. This is some of our saddle bracket designs that we've used in the past. Many of y'all have seen these. We just find a spot that's in between the coupling and the rear bearing cap. That's more likely where we find that at. And we're able to put mag pickups around the gear. And generally we're using a split gear in this arrangement. There's another idea that we've done with the GE steam turbine. And we basically, what you don't see here is we've actually have where we mounted this directly onto the old, I should say the inner part of the front stander of the GE turbine, and then we brought it up and we have it wrap around the gear and get a good mag pickup signal there. This is another one that you can use in certain applications where we actually remove the PG governor, and we can put the mag pickup right directly in place of the where the PG governor went. And this application can only be used if a customer is not requiring a low-end speed control. An example is this usually turns 3 or 4 times slower than the turbine. So if somebody's wanting to operate their turbine down to 500 RPMs, this wouldn't turn fast enough to give us a good signal for our mag pickups. This particular application, the customer minimum speed was 2800, so we were fine. Here's where we modified that previous design that we did for cross oil. The customer asked us if we could do the same thing, and he needed to have his lube oil pump on the end. Again, this was an Elliott, and and so we had designed that IMO oil pump drive so we could use that with our pickup, with our Tach Kit. Here's another view of that. Kind of shows you the internal workings of it, where we actually, this goes in just like the old TG governor used to go into there. This was a pre-picture, or I should say the picture of before, of a Pacific steam pump. And what makes this application so unique is these governors that are on here. This is a UG8PL, and this is a very extremely hot application. And if anybody has any of these in their territories, or if they're familiar with this, what you're going to see next is really makes it nice when a customer, because this is a problem, because those governors cook in that V right there. What we did is if you see right here, this is where the drive used to come in, and here was our cover plate, or I should say where the UG8PL used to bolt to the turbine. We added this device, right, or this adapter here, and then we have a bracket that comes up, and we have a Valtek actuator that comes up and attaches to the same point that the linkage from the UG8PL used to. Works very well. This is our GCS Tachometer kit. Of course, we have the horizontal and vertical versions of it. This is probably the most common one that we sell. Also, for our PGPLs, we have a Tach Kit, and we have different versions of this depending on the basis for your Woodward PGPL. This here is a 2 out of 3 voting trip device that we've manufactured, and we've done this for customers that don't require the SIL ratings that the newer Quick Trip or the Woodward Quick Trip has developed, or that's coming out. But this works really well also if you have any customers that are interested in that. Here's some more of the retrofit kits that we've done for them. This was one for a Cherry GAF steam turbine where we removed the TG governor. I'm sorry, this had the mechanical governor on it, and we actually removed the Cherry mechanical governor and installed the TG. We have an adapter kit, if you see here to the right of the screen. We have an adapter kit that basically drives the TG, and then we have the long linkage that comes up to the steam valve. Here's another one for our Elliots. This is one of our real common kits that we use. We refer to this as the old Elliots, like a bullet governor. It's just a mechanical flyweights in, and what we do here on the right where my cursor is what we do is we remove that bullet governor or the housing here and all of the shaft and all of the flyweights that go up in there. We also provide the customer with a new trip hub that they can use, and then the trip hub has a stub shaft on it that eventually drives the Woodward TG governor. On the steam valve side of it, our bracket attaches to the bonnets, or I should say, to the bolts that go through the bonnet, and we have the linkage that, again, that right here in the center. You'll see the linkage here that attaches the steam valve to the TG governor. This was another another application where it was kind of unique. This is the old mechanical governor here. And all it really does is have big spring and some big flyweights on the inside. And the customer asked us if we could put a TG on there. So if you see to the right, what we did is we developed a bracket or a housing that we could actually attach to the old rotor, and we came up and we're driving the TG, and we also have the brackets that allow us to operate the steam valve. This worked very well. Matter of fact, the customer sent 2 more in for us to do to retrofit. We should be having a second one in our shop here in the next week or so. This is our kit for a Worthington U2R steam turbine. If you look right here where my cursor is, this is where the old mechanical governor used to be. So what we've done is we modified the front housing here, and we drive our TG through there. And then, of course, we have our standoffs that we come off of the valve bonnet, and we have our linkage that we can then allow the TG to operate the steam valve. If you see that, generally we just go through 2 bolts right there on the bonnet of the steam valve. This is a kit that we made to take a Woodward TG lever and convert it to a a pneumatic speed input, so we can take a 3 to 15 air signal and bring it into the speed setting lever, which is right here on the TG, and we can give a customer the opportunity to, or I should say, he can go in with some of his equipment to vary the speed of the TG without doing it mechanically. Here's another before and after picture. This was where we actually applied an XLR actuation, and if you see on the left is the old system, and on the right is after. This is what it looked like after we put the XLR in. And what we did is we just came here and we're attached right to the same valve, to rotary valve rack, and we have our gears that come up and move it up and down. This is a tool that GCS has now that makes our mechanical adaptation a lot easier for our engineering people. And this, what you're seeing here, was actually the old mechanical governor that was, or the actuator that was on the sewage and water board, one of the previous slides that I had showed, the Faro arm. And what we're able to do is you take this Faro arm and you can actually take and design your drawing right from taking measurements, right, or I should say all they do really is they touch the shaft or the design in the middle or any place that they need here, and it makes the drawing for them. So it takes away a lot of the guesswork. This is shown here in our shop, but this can be taken out into the field. And what makes it very handy is you can go out into the field and you can actually draw the front standard of a turbine and then anything that you think may be interfering with your design. And then when you come back, you can put it all together, and then you can see, you'll have the measurements of the whole thing. We've actually done some redesign work on some other things for some customers that's asked us to, if something is broken or beyond repair, we can come in and re-engineer it for them. This is a little bit more information. It's a little better describes it than what I did. We get much closer working tolerance than working with the traditional measuring tools, and the ability to draw parts directly in solid work while measuring are being taken place. That's the keys for that. I think we can, let's see how this will work. I may be able to get you to where you can actually see this taking place.
Servo, the world's most trusted source for 3D measurement technology, develops a revolutionary portable measurement and imaging solution. Servo's commitment extends well beyond product performance and constant innovation in order to build an ongoing relationship with our customers and help make their products and processes the best in the world. The Servo Edge is a portable measurement arm that allows manufacturers to easily verify their product quality by performing inspections, tool certifications, and part analysis and reverse engineering. With the Edge, you can improve production, quality, and reverse engineering processes by rapidly verifying or scanning parts with confidence and accuracy. It's easy to understand how a Servo arm like the Edge works. First, there is a probe at the end of the Servo arm that takes measurement points on command. The user simply clicks a button to record a point, and special encoders compute the exact position of the probe within a three-dimensional space. This point is recorded in the software, and the user moves on to take another measurement. Andritz Hydro operates in renewable energies, manufacturing components for hydroelectric power generation. For years, they have used various measurement systems from Servo for portable, precise measuring tasks, all for the purpose of quality assurance. The Servo Edge's industry-leading features make it the ideal tool for companies constrained by the limitations of fixed CMMs and other portable measurement arms. The Edge is the first-ever smart measurement arm. With a built-in touchscreen and an onboard operating system, it becomes your personal measurement assistant without the need for a separate computer. Standalone basic measurement capabilities give Servo the Edge, taking portable metrology to the next level. The Servo Edge scale arm combines the convenience of a Servo arm with the world's smallest, lightest, and most affordable laser line probe to form the perfect compact, non-contact portable measurement system. At Servo, our focus is on simplifying our customers' work with tools like the Edge that empower them to dramatically reduce on-site measuring time and lower overall costs. Today, thousands of customers worldwide trust and work successfully with various Servo solutions, making Servo the world's most trusted source for 3D measurement technology. The Servo Edge, the world's most innovative measurement arm.
Okay. That explains a little bit better than what I can about what the Servo arm does. Here's some examples of the things that we've actually drawn with the Servo arm. This was the actual device that we used to hold up the actuator for the New Orleans Sewage and Water Board. This is a front standard housing that we drew for a customer, and of course we saw the Dow Chemical project that we drew that whole entire actuator, or the power piston and the pilot valve area there. And I think that's going to be it for today. Thanks, guys, for attending. Does anybody have any questions?
Yeah, Kenny, I have a question. For the non-seal 3 rated hydraulic block assembly that we have, what's the price on that?
I'll have to get back to you, Sonny, but we've got one here, so it wouldn't be too hard to get your pricing on that.
Okay. All right.
Anybody else? Any other questions?